Welcome to our lecture on application of MCU technology. I am your lecturer, Chin Wei Jun. In this chapter, we are going to learn the fundamentals of the Intel MCS51. Next, we will proceed with learning the following four sections: 1. The concept of MCU, 2. The architecture of MCU, 3. Common packaging forms of MCU, 4. Applications of MCU. When it comes to MCUs, everyone tends to feel a bit unfamiliar. First of all, I'd like to ask you a question. What is our computer composed of? Yes, it consists of hardware and software systems. The hardware system includes a host and peripherals. The host is composed of CPU and memory. The memory is further divided into read-only memory, ROM, and program memory, RAM. Peripherals are also diverse, including mice, keyboards, scanners, and so on. So, what is an MCU? An MCU employs ultra-large-scale integrated circuit technology to consolidate the basic components of a computer system into a single circuit chip. An MCU is akin to a microcomputer. It can be connected to external circuits to achieve control functions based on the designer's requirements. So, it is also known as a microcontroller. Taking the Intel MCS51 as an example, here are its key features. Two 16-bit timers, counters. A control circuit for external expandable and addressable 64 KB external RAM and 64 KB external ROM. For 8-bit parallel I/O ports. I/O is an input-output module mainly used for communication between external circuits and the CPU. And an 8-bit CPU. The Central Processing Unit, CPU, also known as the microprocessor, is the core component of an MCU, the control and command center of the MCU. The CPU is principally composed of an arithmetic unit and a control unit. The arithmetic unit performs arithmetic, logical, and bitwise operations on data, akin to how our human brains handle mathematical calculations like 3 + 4 = 7 and make logical decisions like I need an umbrella as it's going to rain today. It is made up of arithmetic logic unit, ALU, accumulator A, general purpose register B, scratchpad memory, SPM, program status word, PSW, etc. The control unit sends control signals, much like the brain controls the movement of the feet and the coordination of hand movements. It is composed of a program counter, PC, an instruction register, IR, an instruction decoder, ID, an oscillator, and a timing circuit. 128-byte RAM, data memory, and 4 KB ROM, program memory. Program memory, also known as read-only memory, ROM, stores raw data, tables, and user-compiled programs. During runtime, the CPU reads an instruction directly from the ROM and then executes that instruction. The temporary data generated during instruction execution, such as variables, is stored in the data memory. How does an MCU work? Firstly, the written program is burned into the ROM of the MCU. Then, the program instructions are fed into the CPU one by one for execution. For example, the CPU can output a low level through the I/O port via program instructions to activate the external indicator lights. When the program contains arithmetic instructions, the CPU will execute them. If there are any intermediate data or variables generated during this process, they will be stored in the random access memory. Common forms of MCUs include the PDIP, plastic dual inline package, and the TQFP, thin quad flat package, and others. The last image shows an MCU application system with peripheral circuits. MCUs are small in size, highly integrated, and compact enough to hold in the hand. They are extensively used in various fields. For example, a microcomputer washing machine can achieve fully automatic washing functions through program settings. A smart refrigerator can intelligently adjust temperature and humidity based on different partitions. With fingerprints or passwords recorded, the smart door lock will recognize the correct information to open the door. And other interconnected household appliances will also be activated, such as robot mops, remote-controlled televisions, bus card readers, and so on. To use such a tiny chip normally, it is necessary to build a correct peripheral circuit according to user requirements, write corresponding control instructions in a program, burn the program into the MCU, and launch the program after debugging. In this lesson, we are going to use C51 as the programming language for developing MCUs. C51 is a variant of the C language tailored for developing the Intel MCS51. In addition, we can use the assembly language for programming. If you are interested in it, explore it in your spare time. Finally, let's summarize. A microcontroller unit, MCU, refers to a highly integrated microcomputer on a single integrated circuit. It consolidates a central processing unit, CPU, that receives instructions and processes signals, a memory that stores data and instructions, and an I/O port responsible for signal input and output. MCUs rely on user-compiled programs to achieve their functions. Either the C language or assembly language can be used for programming. The program sends signals through the pins of the control chip after instructions are processed by the CPU, thus controlling the electrical status of the peripheral circuits connected to the microcontroller pins. Microcontroller units are widely used in various fields of social life. To deepen your understanding of what we've covered in this lesson, please complete the following exercises. See you in the next lecture.